Hey, I'm Colin Lacey, and today we're going to talk about NATS JetStream. And JetStream, if you're not familiar with it, is the underlying data storage capability that you can activate in your NATS cluster. And JetStream comes with a few different capabilities. Today we're going to look at configuration, streams, so the actual storing of data in your NATS cluster, and different retention policies. We are going to look at consumers in the future, but that'll be for a different video because there is a lot to talk about when it comes to consumers. If you haven't seen my previous video, I definitely recommend you go back and watch it. It covers the NATS services framework, but I'm using the same supercluster architecture that I used in that previous video to deploy my stream. So I've got supercluster running in two Kubernetes clusters, one in EKS over here on the East Coast of the US and one in Azure running here over on the West Coast. I've got 4 services stood up that are handling requests and sending responses, right? A adder over here on the West, a multiplier, subtractor, and divider, so that when a requester service, a job that I'm standing up, sends requests with numbers, 2 numbers, any random numbers, to each of these services, they will respond, right? And you can see it's happening across the country. They'll respond to this requester with a response. Here's what these 2 numbers add up to. Here's what they subtract to, etc. Even though these are spanning across the country, and even though these are Kubernetes clusters, there are NATS clusters in them, and they are super clustered together. Again, if you haven't seen that video, highly recommend you go back and watch it. So this requester then is going to send each response that it gets to a NATS stream. What's a NATS stream? Well, let's take a look at that. A NATS stream is dedicated data storage for a series of subjects, and you name that stream and you give it however many subjects that you want, right? And NATS is going to store the data that comes in through those subjects, and it can store them in replication, right? Because our NATS servers are clustered together. You can add replication so that instead of just storing once, it'll store your data multiple times, so that if one of these NAT servers goes down, one of these disks get corrupted, you have a backup copy for high availability. That's awesome. And each of your services that are communicating with NATs are going to send data to that stream. NATS is going to automatically take care of storing it for you. You don't really have to set up much, and I'm going to show you how little it takes. So with that architecture, when my requester sends information, here's all the responses I got back about addition, subtraction, multiplication, and division, it's going to send that data to a NATS stream living over here in EKS. And NATS is going to store those responses, each response it gets, locally, so that later in my next video, a consumer can pick that up. Now, I don't have any consumers stood up, right? So this data, this stream is going to store it for whenever I actually get around to recording that video. So it'll be there, right? That's that guaranteed at least once delivery. Even if you don't have any consumers, the stream will retain that data for you. Awesome. Now, diagrams are great and everything, but let's see what this looks like in real life. So here's my configuration, right? So this, I'm just showing you my EKS cluster right now. My Azure cluster looks pretty similar. One difference between this video and my last video, in the last one, I used username and password to connect everything to my NATS clusters. This time I'm using TLS. Why? Because it's awesome. That's why. So in all these examples, you'll see me connecting everything over TLS. And right here, you can see I've enabled JetStream in my NATS supercluster. So this is where I said, okay, NATS, start setting up storage, because there will be accounts that want to use JetStream. And at the cluster level, this is where you set it, but you also have to activate it at the account level. So down here in Team A, this is the account that I'm using for all of my services that I'm going to demo, right? I also have to enable JetStream for the account. So keep that in mind, right? Once those 2 configurations are set, JetStream's ready to go. as long as your underlying infrastructure has a storage mechanism that JetStream can use, a PVC in Kubernetes world, you can set JetStream and you're done. There's other configurations that you can get into. There's other management configurations. But for now, for my purposes, the simplest approach, JetStream is enabled. Now, I mentioned that I have a requester that's going to send data to my stream. So this is the user for the requester that I've set up here. And you can see it's using a common name from a TLS certificate, and it's going to publish requests to the math.numbers wildcard subject, and then it's going to also publish to the answers.wildcard. So it's publishing a request, and then it's publishing, here are all the responses I got back. Exactly what we talked about in the diagram. What does that look like? Well, it's over here. Now, for the most part, not much has changed about this file since my last video, so I won't cover all of it, but I will point out I did change to TLS, right? So you use an SSL context to set up your TLS connection. And then down here, this is where things are really changing. So as I mentioned before, I'm looping over add, subtract, multiply, and divide. And I've got, for a range in a loop count, my loop count this time is 100. My last time, I think it was 10. For a range in a loop count, I'm going to send a pair of random numbers to each subject and then get a response. That response then, I'm going to publish to one of two subjects back to my stream. If the response is greater than 1, I'm going to consider that significant. I'm going to publish it to answers.significant. If it's less than 1, I will publish it to answers.throwaway. Seems like a pretty standard data cleansing type activity. So we can expect that when I publish these, they'll all live on this answers stream. So what does an answers stream look like? Well, let's look at some of our options for how we would set up a stream. When we're dealing with JetStream, like, we actually have a lot of different options to configure our streams and consumers. You can use the CLI, which a lot of the documentation shows you how to do. You can use Terraform or OpenTofu, which I'm going to do. You can use GitHub Actions, and you can also use a Kubernetes JetStream controller. So for me, I'm going to use this OpenTofu provider to configure my streams and my consumers. If we come back into VS Code, you can see what that looks like. I've got my provider set up, and again, I'm using TLS to make this connection. So I've got my provider set up, and here's all my TLS info that I'm passing in. And then in main.tf, here it is. This is my JetStream stream resource. Okay, so we're going to dive through some of these configuration options in just a second. So if we come into a terminal window, I can say NATS stream ls, and we can see how many streams I have. I don't have any. Let's change that. Let's apply this tofu configuration right here. So I'm going to tofu plan, out plan. I'm going to point to my EKS TF vars, and that's where I'm setting my TLS information, right? My TLS certificates, the server endpoint that I'm going to connect to. Hit enter. It's going to plan, and it's going to create a stream. Cool. That stream has, if we come back in here, 2 subjects, right? The stream name is answers, and the storage is file. This is important. This is how you set that disk durability for your data. If you used the storage memory mechanism, it would be a stream, it would work, but it would store data in memory. I don't want that. I want to store data on disk. So I'm going to apply tofu apply plan. Cool. And now my stream is set. So if I come back up to the top and I say NATS stream ls, I've got an answers stream. That's great. Now, there's a bunch of things that I skipped over right here that I want to talk about. And you can see I've got a consumer set up. As I mentioned, we'll cover that in another video. But all of these different options set data storage limits. So if you're worried about how am I going to make sure that I'm not overloading my disk or running out of disk space, well, this allows you to set limits so that NATS cleans up your data automatically. So let's take a look at what my maximums are right now. If I come in here and I say NATS stream info answers, my maximums are all set to be unlimited, which means I'm just going to keep on piling data on without any data cleanup. That's not great. Okay. So if I run my job right now, kubectl apply file, k8s configs requester. Oop, there we go. Requester.yaml. So this is my requester job, right? I'm going to apply this job. Cool. So if I want to see all that data populating in my stream, I'll come over here and I'll say NATS stream ls. Great. And hey, there's my 400 messages. Awesome. It's got 46 kilobytes, right? And the last message came in 17 seconds ago. That's interesting that I pointed that out. Why did I point that out? Well, let's come back to these max retention options. So if I want to set max bytes to 1 kilobyte, that's it. So right now, remember, 46 kilobytes, I'm going to set this to 1 kilobyte. I'm going to lose a lot of data, right? Let's find out how much data. I'll tofu plan. Yep, and I want a tofu apply. Very cool. So come back to the top. How much did I lose? Well, that's streamls. 8 messages. I have 8 messages left. It all has to sit under this 1 kilobyte limit. That's not much data, but at least I can have my 8 messages, right? If I come in here and I see max messages, well, I set this to 30 when I was setting this up, but now that I only have 8, let's set this to 5. I want to set it to 5 messages. So I can say, just give me 5 messages. The latest 5 messages, don't care what they are. I can do that. You're probably not going to do that in production. Don't do that in production. But let me tofu plan. Yep, tofu apply. Cool. And now NATS, let's come back to the top. NATS stream ls, 5 messages. Awesome. I can set it to however many messages I want. If you only want the 1,000 latest messages, you can do that. Now, the other option that you might want to take is set a time window, max age. So for this, you also have to set the duplicate window. I'm not going to go into what duplicates are, but if you want to check out the documentation, you can see there's a lot of information they provide about message deduplication within a certain window. It'll keep track of the NATS message ID header, which should be a unique value, to see, okay, did I get the same message ID header value within this window? If so, it must be a duplicate. Now, again, not going to demo that. It's a little outside the scope of what I'm doing here, but just be aware that it's there. So I'm going to set the max age to 20 seconds. Remember, currently it's unlimited. And in order to do that, I also have to decrease the duplicate window to less than the max age, a configuration setting you just have to be aware of. I come back into my terminal here and I'll tofu plan, out plan, cool. Now I'm saying max age of 20 seconds. It's been like 2 minutes already. So what do we think is going to happen when I tofu apply? Okay, my stream was modified. So on NATS stream ls, they're gone. Why are they gone? Because they were older than 20 seconds. All those messages, right? My last message came in 3 minutes and 30 seconds ago. So all those messages got erased because they were older than the retention time limit. Now, okay, for the rest of this demo, we're actually going to be a little more realistic. I'm going to comment all this out and I'll set a realistic max age of 5 days. Okay, so 60 seconds times 60 is 60 minutes times 24 hours times 5 days. So with this, we will tofu plan out plan. And we'll tofu apply. All right, so now I can come back and deploy my requester one more time. Kubectl, replace. Cool. The original job was deleted. The new job was deployed. Awesome. And now I can see when I come back into this terminal, I can NATS stream ls and I can see data start to populate. 230 messages so far out of the 400 I expect. I'll wait another couple of seconds and we'll get our 400. So that's data retention. And keep in mind, I don't have any consumers, so nothing's consuming any of these messages. They're just sitting on the server waiting for consumers to come along and start consuming them. And as long as a consumer pops up within the next 5 days, that data will be there. So if I say, okay, NATS stream ls, great, there it all is. And remember, it's divided between those two subjects, the answers.significant and answers.throwaway. So if I say NATS stream subjects answers, I'll see, okay, 92 of the responses that I got were throwaway and 308 were significant. So I can use those two different subjects in my consumers to do different things with them, right? Or I can just fire hose both subjects into the same consumer and store it or analyze it for later. That's powerful. Look at all the stuff that I can do to manage my data retention and manage the data and how it's streamed to my consumers when we get there. So next step will be to set up consumers and look at all the different ways we can pull data from this data store. Again, data is just sitting there for 5 days. Once I set up a consumer, as long as it's within 5 days, that data will be there to start pulling. And we'll look at that in the next video. Thanks for watching.